Hello, in this video I'm going to review the concept of the price elasticity of demand, and I'll be using calculus to demonstrate this issue. So the price elasticity of demand is just about measuring the sensitivity in quantity demanded from a change in price. Let's imagine that we have a demand equation, linear demand equation, where the quantity demanded is a function of price. And given this linear demand equation, let's talk about the price elasticity of demand. So the price elasticity of demand, I'll abbreviate it as E subscript P, can be thought of as the percentage change divided in percentage change in quantity demanded divided by the percentage change in price. The percentage change in quantity is given by the change in Q divided by Q, and we can think of the change in Q, for example, as Q subscript 1 just minus Q. So we have the percentage change in quantity, all of this, divided by the percentage change in price, and the shorthand notation for that will look like this. Here again, the delta P, or change in P, is P1 minus P. Now we could simplify this a little bit, make it a little bit more attractive by doing the following. Let's get rid of this big mess here in the denominator by multiplying through its reciprocal. And if we do that to the bottom, the denominator, we have to do it to the numerator. And so these p's will cancel, the change in p's will cancel, and now we're left with this expression. And let me just rewrite that slightly here. Let me put the changes together, collect the change terms. So the change in Q divided by the change in P times P divided by Q. This is the basic equation for the price elasticity of demand. All it's telling us is that the price elasticity of demand, the percent change in quantity demanded divided by the percent change in price, is nothing more than this term here multiplied by price divided by quantity. Well, this first term here, change in Q over change in P, is nothing more than the slope of this linear demand equation. Okay, so note that the slope of this equation, you would say as well, change in Q over change in P, is just this term right here, minus B. Okay? So therefore, with a linear demand equation, the price elasticity of demand is nothing more than minus B times price divided by quantity, where this first term here, minus the demand curve is downward sloping, there's an inverse relationship between price and quantity. So you're just picking up that parameter in front of the P term, and then you're going to multiply it by some P and Q. Which P and Q? Well, you might be told to evaluate the elasticity of demand at a price of, say, whatever, $2, $5, whatever the problem states. We'll do an example in a minute. All right, let me get a fresh page here. Okay, so just to reiterate then, the price elasticity of demand is given by the following expression. Now you might ask, well, how does this, relate to Now you might be wondering, how this relates to calculus. Well, that's not a big deal. The main thing to know about calculus is that a derivative is nothing more than a slope function of the original equation. So to have this apply to calculus, instead of writing the following expression, we will change these deltas into derivative notation. In other words, we're going to take the derivative of the demand equation with respect to price, and all you're going to get back is the slope multiplied by the ratio of P to Q. All right, with that set up, let me do an example. I'll go over here. So let's say you are given a demand equation. Q equals 10 minus 1/2 times P, the price. And you might be interested in finding the price elasticity demand at a price of $4. Okay, so let's go ahead and apply our formula from the price elasticity demand here. We're going to take the derivative of the demand equation with respect to price and then multiply it by P divided by Q. Okay, this first part here, as we know, is just going to be our slope, which is just minus 1/2. Then we're going to multiply it by P. Well, what is P? It's $4. The only thing we don't know is Q. What Q are we going to use? To figure out the value of Q, what you want to do is take this $4 and plug it back into the demand equation to see what Q equals at a price of $4. So I'll just go over here and 10 minus 1/2 times P, where we're trying to calculate the price elasticity demand at a price of $4. So we solve this and we're going to get a value of 8. So this is the 8 that we're going to plug into our equation here. Alright, so coming down here then, the price elasticity of demand is minus 1/2 times P, which is 4. And when P is 4, we just saw that Q is 8. This is going to equal minus 4 over 16, or minus 1/4. Let's don't lose sight of the interpretation here. This tells us that, at least at this point on the demand equation, that if price were to increase by 1%, quantity demanded would fall by 1/4 of a percent, 0.25%. Okay, so that would be the interpretation. A 1% increase in price would lead quantity demanded to fall by 1/4 of a percent, 0.25%. Okay, if you want, write it into form of decimals. All right, let's do another example. In this example, let's use our same demand equation. Q equals 10 minus 1/2 P. But this time, let's find the price elasticity of demand where P equals $16. So we set up our equation that we proved and solved for. The derivative of this equation with respect to price is just going to be minus 1/2 multiplied by P. In this case, we're letting P equal 16. We don't know what Q is, so let's go ahead and solve for Q when P equals 16. In this case, Q equals 2. 10 minus 1/2 of 16, or 8, so 10 minus 8 is 2. And we get minus 16 divided by 4, or minus 4. So the price elasticity of demand when demand equals 16 is minus 4. This is no accident. As you might already know, the price elasticity of demand varies at every point along a demand curve. Give me a different price and I'll give you a different price elasticity of demand at that price. The interpretation here, again, strictly speaking, is that a 1% increase in price would cause quantity demanded to fall, this time by 4%. A full 4% decrease in quantity demanded from a 1% increase in price. Okay, let me do one more example. On this example, I just want to caution you that sometimes you may be given a demand equation in this form. Instead of having Q on the left-hand side, you have price. In other words, you have price as a function of quantity. So you may be asked to calculate the price elasticity of demand where you're presented with a demand equation in this form. Technically, this is called an inverse demand. This is an inverse demand equation. So if you're presented with an inverse demand, the easiest thing to do is to turn it back into a normal demand equation. Solve this equation for Q. Okay, so go ahead and solve this for Q. So let me go ahead and isolate Q by itself. And you'll get something like this. Now let's go ahead and solve this price elasticity demand. The first thing we need is to calculate it as some price or quantity. So let's calculate this at, say, price equals $30. If P is 30, what is the price elasticity demand? Okay, so we're going to get our coefficient here in front of the P term, minus 4. Going to multiply that by 30. We need to figure out what is a Q when P is 30. So over here, 160 minus 4 times P, where P is 30, we're going to get a value of 40. So go ahead and substitute 40 in for Q. Oops, this is just 4 here, sorry. So substituting 40 in for Q, we're going to get 120 over 40, or just minus, oops, get my minus in there, minus 3. So you just need to be careful in solving these price elasticities demand. If you get an inverse demand, go ahead and solve for Q to get it into the regular demand functional form. Okay, I hope you found this video helpful.